All right, let's get started. So in the last class, we looked at this. We looked at pointers. We looked at a function to write a swap function which can swap the contents of two variables. So in today's class, we will start looking at arrays and yeah, let's see how it goes. So in arrays, yeah, so let me start writing the code, and as I write the code, so here, uh, so here on line number 7, we have declared an array. Okay, so actually it can be, it need not be max underscore size. Let's take it simple. So let's say we call it as so on line 7, you can see that we declared a variable a, and within after the variable a, within square brackets, we have put a value called 10. What it tells is that we are declaring a local variable, that the variable a, no, it is an array of 10 integers. That's what it means. So if you look at your memory, you know what, you know the size of each element of each integer is 4 bytes. So if you look at the memory, so this is you will see that so you have 0th element a of 0, a of 1. So a consecutive sequence of 10 integers, or memory for a consecutive sequence of 10 integers will be allocated. And the 0th element, and the indexing starts from 0. It's not from a of 1, a of 2, a of 3. A of 0 is the 0th element, a of 1 is the first element, a of 2 is the second element, so on and so forth. And if you see, within every element, it is allocated 4 bytes. So this is the 0th byte, this is the second byte, first byte, second byte, and 4 bytes. So 4 bytes are allocated to a of 0. 4 bytes are allocated to a of 0. So similarly, so that means if the address of the element a of 0, if this is equal to 100, then the address of the element a of 1, this will be equal to 104. And the address of the element a of 2 will be 108, so on and so forth. So this is the first idea. The second idea is if you see the element, the variable a is in fact a pointer. It's a very kind of, that's what under the hood, variable a is a pointer, and it contains the address of the 0th element, or the base address of the array. The variable a contains the base address of the array. So what happens is when we try to access an element a of I, internally this gets translated to star of a plus I. That is, you take the base address of the array that is present in the variable a and add I to it. But adding I, what happens is implicitly what the compiler does is, this is what the user view. Under the hood, what compiler does is, it in order to get the raw address, it multiplies this I with the I with 4, because 4 is the size of each uh, array element. That is an integer. So at the user level, if you want to access an array element, either you can use a of I, or you can use star of a plus I. Remember in the last class when we apply a star operator, so that means you go to that address and you get the contents of that memory location. So that's what we do. So star of A plus I means you go to a uh, that address. From that address you read the data. So this A of I gets translated to star of A plus I, or both of them are equivalent to each other. But under the hood, uh, so ith element is obtained by adding 4 times I. Are you all with me here on this one? We will try to write some small code to enforce these ideas. Yeah, A of 0 to A of 9. That's true. A of 0 to A of 9. Someone raised a hand, other. Who raised the hand? Someone raised a hand, but it's now. Anyway, let's try to. So, and then, yeah, so let's write code for this. Yeah, if you have char A of 10, then each element is of size 1 byte. Right? So, maybe we can also have that char B of 10. We will do that. So let's print address of all right. So now let's compile this code. gcc maxarray.c. Yeah, there are a bunch of warnings. Don't pay attention to them. It's okay. So now if you pay attention here, guys. So the base address of the array is this. The base address of the array is this. The base address of the array is present in the variable A. And the base address of the array and the address of the 0th element of the array will be the same. So you can see this address and this address is matching. Are you all with me here on the first thing? The huge number that you are seeing now, that is the address number. So the base address of the array and the address of the 0th element are the same. And that address is present in the variable A. That address is present in the variable A. And then on the next line, you have the address of the variable A of 1. If you want to compute the address of the variable A of 1, you take the contents of A and add 1. But this is not 1, but actually this gets translated to A plus 4 star 1 under the hood. This happens under the hood because because the size of each element is The size of each element is 4 bytes. So you can see the address of A of 2 is you take 64 and add 4 to it, you get 68. You take 68 and add 4, you get 72. So address of the next element is obtained by adding 4 to the address of the previous element. So now, but if you look at the array B, which is a character array, the address of the base address of the character array is this, and B contains the variable B contains the base address. And you can see the address of the next element is obtained by adding 1 to the address of the previous element. Are you all with me here so far? Are doing all right? Any questions here? What are the two ideas here? So an array, it's a list of elements. They are laid out consecutively in the memory. The base address of the array is available in the array. So A acts as a pointer. The variable A acts as a pointer. It contains the address of the 0th element of the array. So the way the array name, it acts as a pointer. It contains the address of the 0th element of the array. And that you can see from here. I want to highlight one more time that this and these two addresses are the same. These two addresses are the same. Right? So now let's go back to the code. So when we go back, let's comment this out. And so this is the first idea. The second idea is this, okay? So for I is equal to 0, I less than 10, plus I, what do? LU stands for long unsigned. So it's so one more thing I would like to point here. You know, the variable I am declaring it as int I on line 22. That means the scope of the variable I is within that for loop. It is not available outside the for loop. How many of you know that thing, that the scope of the variable I declared on line 22, it is available within the for loop. It is not available outside the for loop. Like for example, if you go and write here, I is equal to I plus 1, you can see that the compiler, that the editor is saying, you know, identifier I is undefined. Because the scope of the variable I, which is declared here, it is within this for loop. It is not available outside this for loop. This is a kind of good practice to avoid errors, but sometimes your program may require the scope of the variable I to be available after that for loop also, in which case you make the scope of the variable I broader by declaring it outside the for loop. Are you all with me here on the scope of the variable I before we? Good. Great. So now, yeah, so I have a simple loop. A of I is equal to I star 10. This is the simple loop. And then let's write one more loop to print Okay, don't worry about it. Huh. Did I? Oh, the third percent D, there are 3% Ds. Huh? Actually, I should have this. Yeah. So the point of this exercise is that A of 0 and star of A plus 0, A of 1 and star of A plus 1, these are all the same. So here, I want you to recognize the fact this A plus 1, it is a loaded A plus 1. Loaded A plus 1 means it's internally it gets translated to A plus 4 times 1 because the size of each element is 4. In general, A plus I, if you do, it becomes A plus 4 star I because A is a pointer to an array of integers. So this is what is called as a raw address. This is raw address. This is logical address. Are you with me here? This is raw address. This is logical address. Sorry, this is. Let me clear the screen. Yeah. Yes, Keshav, you are good. All we are doing is we are printing A of. We are trying to access the same element in two different ways. So shall I move on? If you are all doing all right so far. Okay, let's get going. So now one more important idea I would like to uh, put in here is this idea of macros. I think we have seen a bit because we initialized it here, Keshav, on line 22 to 25, A of I is equal to I times 10. Great. So let me delete all this code. So next idea is, so we want to declare the size of, we want to say that we want to use a macro to declare the size of the array A. So what this macro does is wherever max underscore size is there, it gets replaced with by 10 by the C preprocessor. C preprocessor. So if you see here, if I expand, put hover my mouse over here, you can see that the editor says that max underscore size will be replaced with 10. It will be replaced with 10 at the time of compilation. So if you want to notice this, so if you see CPP is the command for C preprocessor. If you do CPP max, uh, it doesn't need a macros doesn't need a semicolon region. Yeah. If you do CPP, a bunch of things will appear, but don't pay attention to them for the time being. Just focus here. So this got this was earlier. This is max underscore size, but it got replaced with 10. This is the code that goes to the compiler. So what happens is, like if you have something like hello.c, this code is first processed by CPP, which is C preprocessor, and then a file called as hello.i gets generated, and this will go to the C compiler. C compiler. But when you use GCC, all these things are automatically done for you. GCC first invokes C preprocessor, which takes care of the macros. And then after that, the generated code will be passed to the C compiler, which does the actual compilation. Are you all with me on the macros front? That what max underscore size, what happens to max underscore size? It just gets replaced with the value 10 that is present there. Are you good? You're all doing all right, guys? Okay. Great then. So now let's get going. So how do we pass? So now what we want to do is we want to write a function to read an array. So I want you to pay attention to the way we pass we declare an array parameter. We say int x or it can be any variable. When you want to pass a single dimensional array, that's what we are dealing with. You just put square brackets with no array size next to it. You just say int x or it can be any name followed by square brackets. That's what we do. And then what do we do? So we write a simple loop while scanf %d ampersand x of I is not equal to end of file I is equal to I plus 1, and we will say int I. You declare int I. So the most important thing here is when we call this read array function, and then finally the size of the array will be written. Whatever the number of elements that is read, it is written. So you read the first element. If you read the first element, then what happens is the value of I gets incremented by 1. After you read the second element, the value of I gets incremented again by 1. So the value of I is equal to 2, so on and so forth. Are you with me on this logic? Yes or no? And here, the way we call this function is size is equal to read array A. So what we are doing here is we are passing the base address of the array. We are passing A as a parameter, and that means we are passing the base address of the array as parameter to the read array function. So that means it is possible for us to manipulate. This should be a note, right? So we are passing the base address of the array. So let's do one thing. So printf A is equal to %d, or I also will put A is equal to %lu %lu I A of sorry. Okay, so here the most important observation I would like you to make is the variable A contains the base address of the array. That base address we are passing as a parameter to the read array function. And because of that, it will be able to successfully read the elements of the array A using the same call by value parameter passing mechanism, right? So let's try to put a breakpoint and trace through this code and see what happens. Let's run the code again. I don't know what happened. Okay, I understood the problem. Just give me a minute. Okay. Start debugging. Yeah. I want to use slash n here. Let me compile the program. Yeah. So first thing I want you to observe is, do you see here the address of the variable a and the address of a of 0? Do you see this? Maybe it is better to, okay, let's see how it goes. So now you can see on the call stack main is present. Why did we have to manually compile, Rahul? Good question. I didn't set up my VS Code properly, so because of it, I have to manually compile. So now you step into, so now if you step into this, you see that X contains some hexadecimal value. It is printing this in the hexadecimal form, but if you print it in the decimal form, this address and this will be the same. So let's do this change in order to be so that I want you to see what is happening. So let's try to compile this program again. Okay, restart debugging. Okay, guys. Again, pay attention here. Now we have printed the address of the variable, that the contents of variable a, which is the base address of the array a in the hexadecimal form. So that is what you are seeing here. So that's what you are seeing here. Are you with me on this first step? We will go through this one step at a time. Are you all with me on this first step that we got the base address of the array A and we just printed it on the screen. We didn't do anything else. And on the call stack, we have main. On the call stack, we have main. Now what we do is we step through the code. So we go to, now you can see when we go through this, when we go to read array, what is present in the variable X? The variable X contains the base address of the array. Are you with me? This is the second important point, that the variable X or the parameter X contains the base address of the array. You can see what is printed on the screen and what is here. These are matching to each other. This is the second observation. This and this and this, these are all the same. Are you with me here? This is the next observation, right? So now, since we have the base address of the array A, then reading and initializing the contents of the array, it is a cakewalk. So that's what we try to do in this while loop. So if you go and see in main, the contents of array A, these are all some garbage values at this point in time. So now let's step through this code. So now we are, it is asking for input, scanf. So let's say I enter 10 as input. So after I enter 10 as input, if you go and see here, what is a of 0? A of 0 is equal to 10, because that's what we read in the while loop now. So because I is equal to 0, so we read the x of 0, and yeah, so that's what we have so far. Does it make sense? And then again you go to again. So now let's say I enter 20. After we enter 20, again you go to main and you see a of 1, it is equal to 20. It is equal to 20. So like that, the code that we have written kind of works out very well, because the variable X or the parameter X contains the base address of the array A. Are you all happy with the logic so far? Any questions? Can I assume that you're all doing good and move forward? So there is a problem in this code. The problem in this code, one problem in this code is let's say if you keep entering input, then it keeps on and taking because, and the while loop doesn't know the size of the array A. So because of that, no, when you give an input which is larger than 10, then the program will behave in an undefined fashion. So how can we fix that problem? That if we enter an input list which is greater than size 10, the program will run buggy. We don't need to pass size. Okay, let's say you pass the size, then what do you do? How can you fix the while loop to take care of it? While I less than or equal to 10 in yeah. So you have to say while I less than max underscore size. Yeah. We just have to add this. So when we add this, it gets taken care of. What happens when I is equal to max size? Will the control go to scanf statement? If I is equal to max size, what happens? When I is equal to max size, then you exit out of the loop because it's an AND condition. If the first condition turns out to be false, you don't evaluate the second condition. That is, what is the second condition? That is scanf, no, blah, blah is not equal to end of file. It will not go to the second condition. If you want to stop it at input 6, we have to give end of file. That's true. If there are only 6 inputs, then you give an end of file and you come out of the program. You come out of the while loop. There are two ways to get out of this while loop. One way is you reach the maximum size of the array. The second is you hit the end of file symbol. These are the two ways by which you can come out of the while loop. All right. So now let's come out of this. So now you read the array. So now you want to print the array. Print array index, and it also takes size. For int I is equal to 0, I less than size plus I. So let's say printf array contents that's it. Does the print array function make sense to you? Does the print array? So what is the use of it? Returns the size of the number of elements it read. In the read array function, you keep track of the number of elements that you are reading. You are returning it and you are passing and you are assigning it to size. So what are we doing in print array? You are just taking two parameters. One is the base address of the array, the other is size, and you are just iterating. You are printing x of 0, you are printing x of 1, you are printing x of 2 until you print all the elements in the array. That's all you are doing. What is there in print array? It's very simple, right? It's just one for loop where you print x of 0, x of 1, x of 2, x of 3, x of 4. That's all. Does this make sense? Yes, no? No, we cannot use max underscore size because the maximum possible size of the array could be 100, but the number of elements that you have read is just 10. So you cannot use, if you just use max underscore size, then let's say if you read only two elements if there are only two elements in the array, then what happens is you end up trying to access the rest of those elements and you print a garbage value. Okay. So let's make this equal to slightly bigger value, 30, and undefined reference to mean. Okay. Right, so 10, 20, 20, minus 1, 0, 32. See, all those values will be printed on this. An important thing is you can redirect output. Like for example, in some file, cat input.txt, I have some numbers before. I can just use this redirection operator. Then the contents of that file will be read and it will be printed on the screen. Does this make sense? You're all good here? So far, how to read and write an array? So now let's try to compute the max of an array, the maximum element present in an array. So this is our goal. So what do we do? So we have something like, we start with an initial estimate. We think that the 0th element is maximum. All right. And then, so we iterate from I is equal to 1. I less than max size plus I. And all we do is, if x of I is greater than max, then max is equal to x of I. Does this code make sense to you? You think that x of 0 is the max, and as you keep iterating, you keep checking if, this is, you keep checking if x of I is, the current element is greater than max, then you do that, and finally I have to return max. That's it. There is no call by reference mechanism at all in C. No, we don't need it. We don't need, there is no such feature also. We do it by making use of, by passing addresses. Does this code make sense? How many of you are with me here on the max array code? The for loop contains an if statement, single if statement. If x of I is greater than max, then max is equal to x of I. That's it. You have a better estimate. And so now you can see print here. So printf maximum is equal to %d, and you call max array, you call a, and you call size. So now let's compile this code. GCC minus G 10, 20, 0, minus 10, minus 20, yeah? And then let's see press. You can see now that the maximum is given as printed as 20. So 10, 20, 0, minus 10, minus 20, control D, maximum is equal to 20. So now I have a question for you. If we have to find the maximum of all the elements except the first element, excluding the first element, how can we find the maximum? How can we find the maximum of all the elements, but we won't exclude the first element? How can we do it? Start from 1. No? I is equal to 1. Put a condition on I. So what if I do this? Ampersand A of 1. Does this work? I pass the base address of the array as the first element and decrease the size of the array by 1. Will this work? Yes or no? So now the base address, from the max array perspective, it doesn't know what is the base address. If you just say A of 1 is the base address, it will just take it as the base address. Dhruv, you don't need max is equal to x of 1, nothing. The max address, max array code remains the same, but we pass the base address as the address of the element A of 1 and decrease the size of the array by 1. So now if you see GCC minus G, this is a modified code, and if you see like 20, 10, 0, minus 10, now you can see that the maximum is 10 because we are looking at the array elements A of 1, A of 2, A of 3 only. Does this make sense? So let's say if you want to find the max of all the elements excluding the last element, what should we do? If you want to find the max of all the elements excluding the last element. Yeah. So all we have to do is you just use address of 0 and just use size minus 1. No, don't change anything. We just want to use max array as it is. So all I am doing here is I am just passing the base address of the array and then saying that the size of the array is, instead of whatever the value, it's less than minus 1. So now let's compile this program. Same stuff we do. 20, 10, 0, 100, control D. You still get the maximum as 20 because we have excluded the last element. Does this make sense to you guys? Is this all good? You're happy with this code? So if you're all doing all right on this one, so I have a challenge problem for you to work. That is, I want you to write code to sort a given list of elements. I want you to code. So what is the idea here? The idea here is, so let's say in sorting, the goal is this. Uh, Let me do one thing. Yeah. So yeah, let's say if you have a list of elements like this, 10 minus 1, 4, 8. So you want to transform this, this into this order, minus 1, 4, 8, 10. This is our goal. So one approach is this, okay? One approach is in this list of elements, you find the smallest element and it turns out to be minus 1. And what you do is you move minus 1 to the first position. So you have minus 1 followed by uh, 10, 4, and 8. You swap minus 1 with 10, and this is what you get. And in the next step, what we do is you leave the green element. This is not bubble sorting. This is, you just look at you leave the green element, and then you look at the rest of the elements, 10, 4, and 8, and you try to find the smallest element, and the smallest element is 8. So what you do is you swap 8 with the first element here, in this first of the red elements. So you have minus 1, 8, sorry, 4, 10. And in the next iteration, you again just focus on the smallest, the red elements, and the smallest of the red elements is 4. So yeah, so what happens is you don't need to do anything here, and in the last step, 10 is the only element that is left. So uh, so the story becomes easy. That's it. Oh, okay. Here, so the smallest is 4, na? Okay. Yeah. So in order to fix my problem, what do I do? I will make, yeah, anyway, you know the idea, right? So, okay, the smallest is 4. We should have taken 4 and swapped it. Yeah, so you make 4 into 14. If I make 4 into 14, then yeah, anyway, you got the idea. So how do you fix it so that what I have done makes sense? Are you all with me here? There is a small mistake I made, but I hope it's make it 9. So yeah, so make it 9 maybe. Yeah, it should be greater than, yeah, I'll make it 9. So if I make it 9, then this will be 9. Good. Thank you. This is a good exercise. 9. Okay, you got the idea. Thank you. So this is the problem that this is what is called as a selection sort. And I would like you to solve the selection sort problem before you come to the next class. Selection sort before you come to the next class. Great. So now if you are fine with this, now I want to move on to the next idea. So this is the problem to solve before the next class. Yeah, you may need a nested loop, maybe. I don't know. Can you hear me? Because I got logged out for some reason. Yeah, so now in the last 10 minutes, so we have for 5 minutes, I'll take 5 more minutes, and I want to introduce you to 2D arrays. So if you see many times when you try to solve problems from math, when you try to solve math problems from the math, you have to work with the matrices. Linear algebra, when you're working with linear algebra especially, you work with matrices. So we will write code to represent matrices and also to add two matrices, matrix add.c. So in order to declare a matrix, okay, so what you do in order to define an m by n matrix, you'll say hash define n2, and so by the line on line number 8, we are declaring a 2 by 2 matrix. So if you are declaring a 2 by 2 matrix, and if you want to access any I comma jth element in the matrix, what you have to do is you use the notation A of I, the notation that you use to access so you use Aij to access the I comma jth entry in the matrix. So if you see the matrix, there are a couple of things I want you. This is a matrix. This is row 0. This is row 1. This is column 0. And this is column 1. So R0, R1, C0, C1. So this element, let's say we call it as A00, A01, A10, A11. In order to access this element, the notation that we use is this. To access this element, the notation that we use is this, so on and so forth. So what happens is this matrix, which is a two-dimensional structure, it gets mapped into memory as a 1D structure because our memory is a linear array of bytes. So what happens is this is like, for example, this is allocated to A00, and then the next one is allocated to A01, and then the next one is allocated to A10, and then the next one is allocated to A11. So your first row is stored A00 and A01 followed by second row. This is what is called as a row major fashion for accessing matrices. Row major storage, row major fashion for mapping your 2D matrices into a single dimensional structure. And within this, of course, you can see there will be 4 bytes. So there will be, this will be 0 first byte, this will be the second byte, this will be the third byte and fourth byte, because the size of each element is 4 bytes. Are you all with me here? That row major fashion, how a 2D structure gets mapped to a linear structure. Yes. This is what is called as a first store row 0, followed by that row 1, followed by that by row 3, followed by row 4, so on and so forth. That is the idea. So now the thing is, we want to read int void read matrix. The second important idea is, and of course we want to print matrix. There are 3 things that we would like to do. We want to read a matrix, we want to print a matrix, and then we want to add 2 matrices, add matrices. So these are the 3 functions we would like to do. So first is, so we would like to have, so 3 matrices, all are of the same dimension, matrices A, B, and C. So we would like to say read matrix A. We kind of say printf enter a percent d cross percent d matrix Ashen. So we want to read two matrices, and then finally we want to add matrices A, B, C. So we want to add the matrices A, B and store it in C, and finally we want to print that matrix sum is as follows. So did you get the structure what we are trying to do? So print matrix C. This is what we want to do. So we want to read two matrices and we want to add the two matrices, and finally we want to print the sum of the two matrices. So an important idea here is when we are trying to read, when we want to pass a matrix, it's important to note if it's a two-dimensional matrix, the first dimension size we don't need to pass, but the second dimension size we have to pass mandatorily, that is required. So I want you to think why the second dimension size is a requirement, whereas the first dimension size we don't need to give. So I just leave it as a challenge, a problem for you to think. But what I want you to understand is in terms of syntax, that when you are trying to pass a matrix, the argument should be defined in such a way that the first dimension has empty square brackets, but the second dimension tells you the number of columns present in the matrix. And that is true for no, for read matrix and print matrix. It's the same. Okay, and if you see for add matrices, where we take three matrices as input, the story remains the same. We take source 1 matrix, source 2 matrix, and then destination matrix. So this is the parameters for the three. So how do we read the matrix? So in order to read the matrix, we write a 2D loop for I is equal to 0, I less than m, plus I, for int j is equal to 0, j less than n. So you first read the 0th row, and then you read the first row, and then second row, so on and so forth. Scanf %d ampersand x of I, x of j. Does the read matrix function make sense to you? I just need couple of more minutes, guys, and then you should be done. Does the read matrix make sense to you? So we are iterating, we are reading one row at a time. When I is equal to 0, the inner for loop iterates through the column and it reads the first row. When I is equal to 1, we read the second row. When I is equal to 2, we read the third row, so on and so forth. Are you all good? I hope you're all good. And then finally, so let's say, how do we print? Control C. So after you first print every row. So instead of scanf, you have printf %d x of ij. So you print every row, and then after you print every row, you print a new line, because you want to go to the next line before you print the current row. Right? This is how you can print. And finally, what is the code for adding two matrices? The code for adding two matrices is very simple. This is dsti J is equal to SRC1 Ij plus SRC2. Does the addition of matrices make sense? Does it make sense to you? We are just iterating through the elements of the matrix. We are adding them together. The I comma jth entry of matrix A and I comma jth entry of matrix B, we are adding it and storing it in the I comma jth entry of the destination matrix. Are you all with me, guys? With me here? It's very simple. The logic is very simple. So now let's compile this code. GCC minus G void main. Okay. Matrix add dot C, control L. So 0, 10, 20, 0. This is the first matrix. Minus 10, 0, no, 0, minus 20. And when we add them together, this is what we get. Does this make sense? This whole story? How we are reading two matrices and then we are adding them and printing them together. Okay, so I want to finish this particular idea so that you will be enabled to work on matrices over the weekend. So that is the reason why we are having all this here. What if you enter all four numbers in a line? No problem, Otherwise, it's a good question. So it doesn't matter even if you enter all four, it will still be read as a matrix, the same matrix. It's not going to change anything for you. It will still be the same. It's not an issue. Good question. I think I'll stop here in the interest of time. So